Hi guys, so hope you are doing well and welcome back to the course on applied probability and statistics. So let's get started. So now in this module we will look at the rest of the three discrete probability distribution, that is categorical distribution, multinomial distribution and Poisson distribution. Okay, so let's proceed ahead. So here comes the first distribution of this lecture, categorical distribution. This is one of the distribution you already may be knowing. It's just a roll of a die. Okay, so the outcomes are here, six possibilities, 1 to 6. Okay, and of course there are six parameters. Okay, that is the probability of outcome. Okay, that is the probability of each outcome. So there are six outcomes and six parameters. uh, Also, one thing to notice here is that some of the parameters will be equal to 1. Why? Because only six parameters are there, only six outcomes are there, and no other outcomes. Okay, so the probabilities are getting distributed across all the outcomes, so sum has to equal to 1. So so that is about categorical distribution. Now let's come back to what's the use. Okay, so now you can see there are six outcomes and those are unknown. So this is used for classification or in some game design. Okay, for example, you are playing a game against one of the outcomes, so you will be rewarded if you are better able to predict the outcomes, you will be rewarded. So that is the application. So it's also used in machine learning for classification problems. uh, so let's get to the next distribution. Yeah, multinomial distribution. So here you need to focus a little more than the categorical distribution, because it is one of the most complicated distribution to understand. Okay, so let's go slowly. So what is it? Imagine there is a dice. Okay, so dice has six outcomes, 1 2 3 4 5 and 6. Now suppose with each of the outcomes I associate a variable. For example, x1 denotes the outcome 1, x2 for 2, x3 for 3, x4 for 4 and so on. Okay, now suppose this dice is tossed n times. Okay, how many times? N times. So these variables x1 will keep a note of the count, how many times 1 appears. For example, when this die is tossed n times, I want to know how many times the outcome 1 appears, how many times the outcome 2 appears, and so on. Okay, so you can see this is not a single variable, this is a collection of 6 variables. Okay, so multinomial distribution is a collection of 6 variables, 6 random variables. Random because you don't know how many times 1 will appear when the die is rolled 10 times. Okay, or n times. That's why these are random variables. So these basically maintains the count of each of the outcomes. Okay, so these are counting variables, I can also say. So each of the variables is maintaining the count or noting the count of how many times certain outcome is occurring when the die is rolled 10 times. Okay, and again, what are the parameters? That is the n is the parameters, that is how many times the dice is being rolled, and the parameter, the probability of each of the occurrence of the outcome. Okay, so 6 outcomes, so 6 probabilities, so 6 probabilities parameters, the sum of the parameters has to equal to 1. Okay, so this is multinomial distribution, and let's come back to an example for that. Okay, so suppose there is a shop. Okay, there is a shop and there are 6 types of dolls. Okay, so there are 6 types of dolls. Now suppose a customer comes. Here customers will be like, let's suppose a very simplified parents and a child. Okay, so a customer comes and buys one of the dolls. So you don't know which dolls they will buy. Okay, so one of the 6 possibilities are there. So one of the outcomes will appear, whether the parents will buy this doll or this doll or this doll. Okay, so so this is like a categorical distribution. Okay, so one of the outcomes is occurring. But now suppose another parents come and again they buy one of them, and so on. So suppose in a day n customers comes and each of the customers may buy one of these 6 dolls. Okay, so the shopkeeper might be interested in knowing which type of dolls are being sold more, or which dolls is being bought more, or what is the expected number of dolls that what is the expected number that this dolls will be bought. So these are the relevant questions the shopkeeper may be interested in. So this is one of the example to show you how it models the how multinomial distribution models this event, okay, or this scenario. So this is all about multinomial distribution I wanted to share. Let's get back to the next distribution, Poisson distribution. Okay, so again, the Poisson distribution gives you a count of occurrence of something, occurrence of some event. Okay, so basically it gives you on an average how many times a certain event occurs. Okay, for example, suppose this is Swiggy. Okay, so Swiggy is interested in knowing in the next 1 hour how many orders will come, because accordingly he can keep the number of delivery partners. Okay, another example is the call center. The call center may be interested in knowing how many calls, customer calls are going to occur in the next 1 hour. Okay, similarly, it would be interesting to know in the next 10 years how many times flood might occur. Okay, so these are the examples of scenarios where Poisson distribution is used to model it. Okay, and why do we do modeling? Because by doing modeling we are predicting. Okay, and if we are able to predict something, we will be rewarded for that. For example, if I know that a certain city is going to face 3 floods, expected number of floods in the next 10 years, I can plan the city. Okay, or I can be prepared for it. Similarly, if Swiggy knows how many orders are going to occur, what is the probability that 10 orders will occur, or 15 orders will occur, or 100 orders will occur, accordingly he can optimize over the allocation of human resources in terms of delivery partner. Okay, so these are the application. So this is all about Poisson distribution I wanted to convey. Hope I made it easy for you guys, and if you like the content, please like and subscribe the channel. So this is where we are going to stop for today. Then we will continue the rest of the distribution, that is the continuous distribution, in the next lecture. Thank you so much. See you again. Bye.